Good day everyone! In this video, we will discuss about the derivatives of algebraic functions. The evaluation of a derivative using the concept of limit may become more tedious to apply for complicated functions. Hence, this lesson will illustrate the basic rules or formulas useful in evaluating the derivative of some functions, particularly algebraic functions. To determine the derivative of algebraic functions without using the limit definition, certain rules are to be considered. It is important to take note as well that these rules may also be applied to transcendental functions such as exponential and trigonometric functions, which will be discussed in the next lesson. Let us start with theorem number 1. Theorem number 1. The constant rule of differentiation. The derivative of a constant function is 0. That is, if a is a real number, then the derivative of a is equal to 0. The rule specifies that the derivative of any constant is always 0. For example, find the derivative of the following functions using the constant rule. Y is equal to 15. Since 15 is a constant number, then dy over dx is equal to 0. For the second one, f of x is equal to square root of 6. Square root of 6 is also a constant number, thus f prime of x is equal to 0. Last one, g of x is equal to 1/5, wherein 1/5 is a constant number, thus g prime is equal to 0. The second theorem is the power rule of differentiation. If n is a rational number, then the power function f of x is equal to x raised to n is differentiable, and d over dx of x raised to n is equal to n times x raised to n minus 1. The rule indicates that to get the derivative of an algebraic function in the power form, we make the exponent n of the power the coefficient, then copy the base x, and then supply the new exponent n minus 1. For example, find the derivative of the following functions using the power rule. Y equals x raised to 3. Remember that d over dx of x raised to n is equal to n times x raised to n minus 1. Thus, d over dx of x cubed will be equal to 3 times x raised to 3 minus 1. Notice here that we have made 3 as the exponent to be the numerical coefficient of the variable. Thus, we will have the final answer to be 3x squared. Another example, f of x is equal to 1 over x raised to 8. We can rewrite first the function f of x equals 1 over x raised to 8 to be x raised to negative 8. From here, we can now solve the derivative of the function wherein we will be using negative 8 to be the numerical coefficient. So we will have f prime of x is equal to negative 8x raised to negative 8 minus 1. Simplifying negative 8 minus 1, we will have negative 8x raised to negative 9. If we want to make negative 9 to become a positive exponent, then we need to get the reciprocal of x raised to negative 9, which is equal to negative 8 over x raised to 9. Another one, g of x is equal to square root of x. Remember that square root of x, when you rewrite that in a rational exponent, it will be equal to x raised to 1/2. From here, it will be easier for us to apply theorem number 2. Make 1/2 to be the numerical coefficient and subtract 1 from the exponent 1/2. Thus, we will have 1/2 x raised to negative 1/2. To make negative 1/2 to be positive, then we will have here 1/2 times 1 over x raised to 1/2 or simply equal to 1 over 2x raised to 1/2. Remember that x raised to 1/2 is equal to square root of x. Thus, the final answer will become 1 over 2 square root of x. Another one. H of x is equal to 1 over x raised to 2/3. Rewrite the function to be x raised to negative 2/3. Make negative 2/3 to be numerical coefficient of x. So therefore, h prime of x is equal to negative 2/3 x raised to negative 2/3 minus 1. Simplify negative 2/3 minus 1, we will have negative 2/3 x raised to negative 5/3. To make this negative exponent positive, we will get its reciprocal. So we will have negative 2 over 3 x raised to 5/3. And remember that x raised to 5/3 is equal to cube root of x raised to 5. Thus, the final answer will become negative 2 over 3 cube root of x raised to 5. And simplifying cube root of x raised to 5, we will have negative 2 over 3x cube root of x squared. Theorem number 3. The constant multiple rule of differentiation. If f is differentiable function and a is a real number, then a times f is also differentiable and the derivative of a times f of x is equal to a times the derivative of f of x. Following the power rule, the constant multiple rule states that we first copy the coefficient, then multiply it to the derivative of the function f of x. For example, find the derivative of the following functions using the constant multiple rule. Y is equal to 2x. So therefore, its derivative will be equal to 2 times the derivative of x. Remember that the derivative of x is equal to 1. Thus, 2 times 1 is equal to 2. Another example, f of x is equal to 5x cubed. So its derivative is equal to 5 times the derivative of x cubed, which is equal to 3x squared. Multiplying 5 and 3, we will get 15x squared. Another example, g of x is equal to 1 over 3x raised to 6. Rewrite first the given function to be 1/3 times x raised to negative 6. To get its derivative, we will have 1/3 times the derivative of x raised to negative 6, which is equal to negative 6x raised to negative 7, because negative 6 minus 1 is equal to negative 7. Multiplying 1/3 and negative 6, we will have negative 2, then a fixed x raised to negative 7. Therefore, the derivative of g of x is equal to negative 2x raised to negative 7. When we write x raised to negative 7 with positive exponent, then we will get negative 2 over x raised to 7. Another example, 4/5 x raised to 1/2. So the derivative will be equal to 4/5 times the derivative of x raised to 1/2, which is equal to 1/2 x raised to negative 1/2. Multiplying 4/5 and 1/2, we will have 2/5 x raised to negative 1/2. To make negative 1/2 positive, we will have 2 over 5 square root of x. Theorem number 4. The sum or difference of two differentiable functions f and g is itself differentiable. The derivative of the sum of f and g is given by d over dx of f of x plus g of x is equal to f prime of x plus g prime of x. And the derivative of the difference of f and g is given by d over dx f of x minus gx is equal to f prime of x minus g prime of x. The rules indicate that the derivatives of f plus g and f minus g are the sum and the difference of the derivatives of f and g respectively. For example, find the derivative of the following functions. Y equals 2 plus 5x quantity squared. From here, we can simplify 2 plus 5x quantity squared to be equal to 4 plus 20x plus 25x squared. Since we have here a trinomial, to get its derivative, we will simply get the derivatives of each term and add them. So that will be equal to 0 plus 20 times 1x raised to 1 minus 1 plus 25 times 2x raised to 2 minus 1. So that will be equal to 20 plus 50x. Another example, 2 over x cubed plus x squared minus 1 over 4 cube root of x. From here, what we need to do first is bring x cubed and cube root of x on the numerator, and with that, their exponents will become negative. Therefore, the function will become 2x raised to negative 3 plus x squared minus 1/4 x raised to negative 1/3. From here, we can now get the derivative of each term. Thus, we will have 2 times negative 3x raised to negative 3 minus 1 plus 2x raised to 2 minus 1 minus 1/4 times negative 1/3 x raised to negative 1/3 minus 1. Simplifying it, we will get negative 6x raised to negative 4 plus 2x plus 1 over 12 x raised to negative 1/3. Let's make these negative exponents positive by bringing them on the denominator. So we will get negative 6 over x raised to 4 plus 2x plus 1 over 12 cube root of x. Another one. Y is equal to x raised to 5 plus x cubed plus 7x minus 2 divided by x squared. Let us divide first each term by x squared. So x raised to 5 divided by x squared is equal to x cubed. X cubed divided by x squared is equal to x. 7x divided by x squared is equal to 7 over x. And negative 2 divided by x squared is equal to negative 2 over x squared. From here, write x and x squared on the numerator. Therefore, their exponents will become negative. We will have x cubed plus x plus 7x raised to negative 1 minus 2x raised to negative 2. Find now its derivative. We will have 3x raised to 3 minus 1 plus 1 times x raised to 1 minus 1 plus 7 times negative 1 x raised to negative 1 minus 1 minus 2 times negative 2x raised to negative 2 minus 1. Simplifying it, we will have 3x squared plus 1 minus 7x raised to negative 2 plus 4x raised to negative 3. Write x raised to negative 2 and x raised to negative 3 at the denominator, so it will become positive. Hence, the final answer will become 3x squared plus 1 minus 7 over x squared plus 4 over x cubed. Theorem number 5. The product rule of differentiation. The product of two differentiable functions f and g is itself differentiable, and its derivative is given by d over dx of f of x times g of x is equal to f of x times g prime of x plus gx times f prime of x. The derivative of the product f of x times g of x is equal to the sum of the product of f of x with the derivative of g of x and the product of the function g of x with the derivative of f of x. For example, find h prime of x if h of x is equal to the product of 3x squared minus 4 and x squared minus 3x. In here, in the given function h of x equals 3x squared minus 4 quantity x squared minus 3x, let h of x be equal to f of x times g of x. Thus, this will become f of x and this will become g of x. Now, let us determine the derivative of f of x and g of x. F prime of x is equal to 6x and g prime of x is equal to 2x minus 3. Since we already have f of x and its derivative and g of x and its derivative, we can now substitute this to the formula to get the derivative of h of x, which is f of x times g prime of x plus g of x times f prime of x. Thus, we will have 3x squared minus 4 quantity 2x minus 3 plus x squared minus 3x quantity 6x. Simplifying both products, we will have 6x cubed minus 9x squared minus 8x plus 12 plus 6x cubed minus 18x squared. Combining like terms, we will have the final answer 12x cubed minus 27x squared minus 8x plus 12. Another example, find h prime of x if h of x is equal to square root of x times 6x cubed plus 2x minus 4. In the given function, h of x is equal to square root of x times 6x cubed plus 2x minus 4. Let h of x be equal to f of x times g of x. Thus, f of x will be equal to square root of x, which is equal to x raised to 1/2. And g of x will be the other factor, 6x cubed plus 2x minus 4. Determine the derivative of f of x and g of x. We will have f prime of x is equal to 1/2 x raised to negative 1/2 and g prime of x is equal to 18x plus 2. Now, substitute f of x, g of x, f prime of x, and g prime of x to the formula. We will get x raised to 1/2 times 18x squared plus 2 plus 6x cubed plus 2x minus 4 times 1/2 x raised to negative 1/2. Simplifying each product here, we will get 18x raised to 5 over 2 plus 2x raised to 1/2 plus 3x raised to 5 over 2 plus x raised to 1/2 minus 2x raised to negative 1/2. Combining like terms, 18x raised to 5 over 2 and 3x raised to 5 over 2 and also 2x raised to 1/2 and x raised to 1/2, we will get 21x raised to 5 over 2 plus 3x raised to 1/2 minus 2x raised to negative 1/2. Rewriting x raised to negative 1/2 as positive exponent, we will get 21x raised to 5/2 plus 3x raised to 1/2 minus 2 over square root of x. The quotient rule of differentiation. The quotient of two differentiable functions f and g is itself differentiable, and its derivative is given by d over dx of f of x over g of x is equal to the product of g of x and f prime of x minus the product of f of x and g prime of x over the square of g of x. The derivative of the quotient f of x over g of x is equal to the difference of the product of g of x with the derivative of f of x and the product of f of x with the derivative of g of x divided by the square of g of x. To apply this rule, let us have this example. Let h of x be equal to 3x plus 5 over x squared plus 4. Let us find h prime of x. Let f of x be equal to the numerator 3x plus 5 and g of x be equal to the denominator x squared plus 4 and determine their derivatives respectively. The derivative of f of x is equal to 3 and the derivative of g of x is equal to 2x. From here, we can now substitute f of x, g of x, f prime of x, and g prime of x to this formula. We will get x squared plus 4 times 3 minus 3x plus 5 quantity 2x over x squared plus 4 quantity squared. Multiplying x squared plus 4 and 3 and 3x plus 5 and 2x, we will get 3x squared plus 12 minus 6x squared plus 10x over x squared plus 4 quantity squared. Next, simplify the numerator by subtracting 6x squared plus 10x to the first binomial. We will get negative 3x squared minus 10x plus 12 all over x raised to 4 plus 8x squared plus 16 when we simplify the denominator x squared plus 4 quantity squared. Another one. Let h of x be equal to 2x raised to 4 plus 7x squared minus 4 divided by 3x raised to 5 plus x raised to 4 minus x plus 1. Find h prime of x. From here, let f of x be the numerator and g of x be the denominator of h of x. Next, find the derivative of f of x and g of x to be 8x cubed plus 14x and 15x raised to 4 plus 4x cubed minus 1 respectively. Next, substitute f of x, g of x, f prime of x, and g prime of x to the formula below. We will get 3x raised to 5 plus x raised to 4 minus x plus 1 times 8x cubed plus 14x minus the product of 2x raised to 4 plus 7x squared minus 4 times 15x raised to 4 plus 4x cubed minus 1 all over 3x raised to 5 plus x raised to 4 minus x plus 1 quantity squared. Simplifying the numerator, we will get negative 6x raised to 8 plus 63x raised to 6 plus 14x raised to 5 minus 54x raised to 4 minus 24x cubed plus 7x squared minus 14x plus 4 all over 3x raised to 5 plus x raised to 4 minus x plus 1 quantity squared. I hope that you have understood the lesson. For our next video, we will discuss about the derivatives of exponential and trigonometric functions. Thank you so much for listening and see you on our next discussion.